Okay, in this video, we're going to do a quick explainer on Faraday's law, okay? And when is the EMF a maximum? When is that magnetic flux a maximum? Okay, now anytime I see a question on magnetic flux, I always draw the same diagram on the side of my test, and I highly recommend that you get used to that too. So you want to draw your magnetic field lines, okay? So remember, how concentrated these magnetic field lines, how dense these magnetic field lines, that tells us our value of B, right? Because B is our magnetic flux density, right? So B, remember, is always measured in Teslas. A is our area. So this is the area they cut through. So let's say it's a coil of wire. So there is my coil of wire. So I think if you've got a coil of wire, you know that it's going to have that circular shape if you look straight on it. So there's my circular shape of my coils of wire, okay? Now what you want to do is draw your normal of that coil of wire. So I'm going to do is draw my normal of that coil of wire. So there's my normal, okay? Now my magnetic field lines, they're all going horizontally, okay? Now the fact that you need to know is that when the normal, just going to write it out, when the normal is parallel to the field lines, okay? So when this normal is parallel to the field lines, that's when our magnetic flux is a maximum, okay? And magnetic flux is this B times A. This symbol here, that represents the change in magnetic flux. So that's when my magnetic flux is a maximum. So basically we're saying when this coil, when the normal is perfectly parallel with these field lines, that's when our magnetic flux is maximum. So when the change in magnetic flux is a maximum, now you're thinking, what happens to our EMF? So just quickly pause here. Again, the way I did it was the normal to be parallel to the field lines. That's when my magnetic flux is a maximum, okay? But another way you can look at this is you can look at the plane of the coil, and it's good practice to know both because sometimes the questions might be orientated slightly weirdly. So we call this the plane of the coil. So for me, it's always easier to find the normal, and then I just know the plane of the coil is always 90 degrees to it. So the plane of the coil is kind of like the surface of it, okay? So here you can see that when the magnetic flux is a maximum, when the normal is parallel, that's when the plane of the coil is perpendicular, okay? And that's when we're going to get our maximum magnetic flux linkage, right? Most of these magnetic field lines passing through it, okay? Now our EMF is to do our change in our magnetic flux over time. And AN just stands for the number of coils of wire, so how many coils of wire we have. Okay, so clearly you can see that the quicker we change the magnetic flux, maybe I'm moving faster, we're going to get a bigger EMF induced. Okay, now the EMF we can see is the change in the magnetic flux over time. So we can see here, normally you've got it in graphs. Okay, so normally we have a rotating coil of wire inside a magnetic field. So here's my coil of wire, and maybe what happens is you have it rotating inside that magnetic field. So you're going to get a changing magnetic flux. So let's say we start with a magnetic flux to be a maximum. We're going to start with the normal, parallel to our field lines. The magnetic flux will change over time as we rotate it, okay? Now, because the EMF is the change in the magnetic flux over time, if this is my magnetic flux against time, you can see the EMF is going to be the gradient of those lines, okay? So you can see here, the gradient there, when the magnetic flux is a maximum, that gradient is 0. So the rule is that the EMF is always a maximum when the magnetic flux is a minimum, and the EMF is a minimum, we just said it was 0, when the magnetic flux is a maximum. So we said here, the magnetic flux is a maximum when the normal is parallel to field lines. So when the normal is parallel to field lines, that's when the EMF induced in our coil will be a minimum, okay? So just make sure you know those facts off, because questions in paper 2, they try to trick you and they'll change the angle sometimes, they'll change the orientation, and it's really important that you understand these facts off and then you just apply it to the question in front of you. So I just highly recommend you write these facts around the side and then you look at your question, try to apply the facts to the question.